let's do this. Now that we're all got the fingers all loose, here we go. All right. So Friday of last week, you should have done the law of signs guided note sheet. If you didn't, they're over there. So we're talking about that. Today, we have to talk about the law of signs, but we have to talk about the ambiguous case of the law of signs. Then tomorrow is just some straight up law of signs practice. Okay? Just some working on that. And the formative that was supposed to be today will be due tomorrow. Okay? Thursday, because Thursday is that goofy, some people were in and out all day with the career fair. So we did a law of cosines discovery sheet, which is very similar to the law of sines discovery sheet. So that if you are called out of class because you've got to go wherever or go to a career fair or something like that, you can easily pick that up. Friday then of this week is going to be comparing, using both of them and all that fun stuff. Now, next week, Tuesday, is ACT Day. So next week, Tuesday, a week from today, you guys don't have class, regular class, because juniors are going to be taking that one. So we'll hand out the worksheet that we then want to have done by next week.
It's not like
So last week, Friday, you should have learned all about the law of signs. And the law of signs is the simple law in terms of law of signs, law of cosines. Law of signs is much easier, but it's more restrictive. So you have to have an angle and its opposite side. You need to have at least one pair of those. Doesn't matter which pair you have, but you've got to have one complete set of an angle and its opposite side in order to use the law of signs. If you have that, then you can solve the rest of the triangle. We're solving triangles here in this stuff. Okay? So the sign of the angle divided by the opposite side, that proportion is the same throughout every single throughout that one particular triangle. Okay? This works on any triangle. Doesn't have to be a right triangle. It's not SOHCAHTOA. This is going to work on any and every single triangle. Okay? The downfall with the law of signs is that, remember, when we were discovering inverse sign, we limited inverse sign to the right half of the unit circle, which means the law of signs only can find an acute angle. So if you have an obtuse triangle and you're trying to find a particular angle, if you're using the law of signs, you have to find the smallest angle first. Okay? Come on now. Now, you may be asking yourself, how do I know which one is the smallest angle? Does anybody know where the smallest angle lies in a triangle? What do you mean the two shortest sides? It's the angle in between the two shortest sides? No. Between the two longest sides. it's opposite the shortest side. Okay? It's opposite the shortest side. Which means the biggest angle would be what? Opposite the longest side. And the medium angle or the middle angle would be opposite the middle side. Okay? So that's a good piece of data to know. Okay? Because when you're using the law of sines, even in the ambiguous case, even in the in just a regular case, you always want to find the smallest angle first. Okay? So let's talk the ambiguous case of the law of sines. So first off, we got to build up what the ambiguous case is. Okay? So there are, in geometry, 5 ways to prove that any two triangles are congruent. Okay? The nice thing is those 5 ways represent combinations that only give you one triangle. Now, we're not going to be proving 2 triangles are congruent. We're just going to be solving 1 triangle. But the 5 ways to prove triangles are congruent also just happen to be the ways that there's only 1 triangle given. So the first way is the side-side-side case. Okay? Which for us, this week and next, is going to mean if you're given the 3 sides of a triangle, there is only 1 triangle. Okay? Now, the downfall with the side-side-side case is it is a law of cosine to solve. So that's going to be later on this week. So we're not going to have any side-side-side cases. Okay. Next one is side-angle side. So if we have a side or two consecutive sides and the angle in between them, that's also only going to produce 1 triangle. But this also is going to give us a law of cosines solid. So that one's going to be later on too. Okay. The next one is angle side angle. Now, this one is a law of sines case. And so for us, instead of saying 2 congruent, we're going to say 2 consecutive. So if you have 2 consecutive angles and the side in between, what I'm talking here is you've got this angle, you've got that angle, and you've got this side right there. That's a law of sines case because the 3 angles of a triangle add up to be how much? 180. So you know this angle then too. And now you've got your complete pair. So this is a law of sines case. Okay? We'll have some of those, but this one will only produce one triangle. The next one is angle side angle. Again, we would be talking about two consecutive angles. And now it's going to be one of the two sides not in between those angles. So let me draw you a picture. So we have two consecutive angles, and we'll say this side. Again, because we know that the triangle sum theorem is out there, we know what this angle then is, and now we have a complete pair. Or we were actually given a complete pair. But now we can use the law of sines to find the other two missing sides. But again, that only works in I don't know what I'm saying. We would solve for the three parts there. Why is it? I don't know. We're looking at the next one. The next one we have only is for a right triangle, and it's hypotenuse leg. So if you have a hypotenuse in one of the legs of the triangle, or of a right triangle, then, but that's different because now you've got SOHCAHTOA. So you can solve a right triangle using SOHCAHTOA. Okay? So, that leaves us with, if we're given one angle and two sides. Okay? All right? So, what I would like you to do right now is I would like you, using the law of sines, because we have that complete set, right? I want you just to find me angle B. Using the law of sines. Go for it. Find me angle B. So law of sines tells me that we should have the sine of 20.5 degrees over 12 equaling the sine of angle B over 31. Do you agree with me on that? Okay? So if I multiply both sides by 31, I would get 31 sines of 20.5 degrees all over 12 equaling the sine of angle B. Agree with me on that? Well, I want angle B, so that means that I got to take the inverse sine of that, right? So I got the inverse sine of all of this. Now, depending upon your calculator, you might have to close some parentheses before you do that. Did anybody get an actual angle measure for this one? 64.8? I got 64.783, but I probably rounded more decimal places than you. Okay? Well, I shouldn't say that. Mrs. Hill got that. Right? Here's the problem. When I did it this morning, I got 115.217. How did I get that? Did I not? Did I do it wrong? Wow! Check mine. Check mine. Put my angle up in here for B. So go 31 times the sine of 220, or 200, times the sine of 20.5, divided by 12, divided by the sine of 115.217, and you should get something very close to 1. Because of the rounding, it won't be exactly. Works, doesn't it? Ruh-roh. One might say, ruh-roh. That, ladies and gentlemen, is the ambiguous case. Now, in English, let me ask you a personal type question for all English people out there. What does ambiguous mean? Not clear? Open to more than one interpretation? Okay. Right? Okay. So not clear. Okay. Doubtful, not clear, or definite, having 2 or more possible meanings as an ambiguous sign. So like Joe's restaurant here, Joe's home cooking, right? Is Joe at home cooking? Because he could be home cooking. Or is his restaurant like what he makes at home? You know what I mean? Okay. So that's what ambiguous is. And the ambiguous case only happens with the law of signs. So that's one. It only happens with the law of signs. And it only happens, and Finn, this makes it easy for me to remember, it only happens when you have an angle side side. Okay? It spells ass. Okay? So it only happens with angle side side. Which is why, back when you were in geometry, your geometry teachers told you you can't prove that triangles are congruent with angle side side. Because it opens up ambiguous cases. Okay? So, given the fact that you have an angle side side case, which means you're only given one angle. Okay? So if that angle is obtuse, meaning, let me draw one in here, draw in an angle side side case. Now what I should do is I should copy this. Come on. Paste it. Okay. So if you are given here angle A, so there's my angle, and then you're given 2 sides. So here would be a side, and here would be a side. It can't be these 2 sides, because then you're in a side angle side case. Okay? So it has to look like that. So I'm going to call this side here the adjacent side. And I'm going to call this side here the opposite side. Okay? Stealing our right triangle trig SOHCAHTOA letter. Okay? Opposite, adjacent. Okay? If the opposite side is bigger than the adjacent side, so if the opposite side is longer than the adjacent side, you're in heaven because only one triangle is formed. And what are you going to use to solve it? What would you use to solve that? Law of sines. Yep, you do law of sines. Okay? Because you have that complete fraction. Yep. Let me get back here. So here's my angle. Here's my side. Here's my side. This would be my adjacent side. This would be my opposite side. Now what I'm going to do is I'm going to say that the opposite side, the other scenario here, would be that the opposite side is shorter than the adjacent side. First off, can that happen? Why not? Even more than that.
It since the obtuse angle will always be the biggest angle, and therefore its opposite should be the biggest.
Exactly. You would get used for that. Good shot, okay? We just talked about how smallest side is opposite the smallest angle, right? Biggest side is opposite the biggest angle. Okay? If our angle is obtuse, that means the opposite side has to be the longest. So there can't be any longer sides in it. So if that's the case, then no triangle is formed. Okay? Now, the given angle is acute. And you have a side and a side. Again, we'll call this the adjacent side. And we'll call this the opposite side. If the opposite side is bigger than the adjacent side, then there is one triangle. You get one triangle, use law of sines, and move on with your life. Okay? So far, if the opposite side is bigger than the adjacent side, in your given statement, you only get one triangle. In both cases, acute or obtuse. Okay? Now, here is where the real ambiguity starts. Okay? Well, here with it first. Get you guys a moment to write it down. So here is my angle A. Here is my side. Here is my side. This side would be the adjacent. This side would be the opposite. Okay. Now, angle A is acute. So, the opposite side doesn't have to be the longest side. So, there are triangles that get formed. Okay? I found this on the web. Easy there, Siri. We're also going to call this the height, just so you know, because we need to know that that height of that triangle is there. So there's three possibilities in this scenario. Okay? Possibility number one is that, tap the brakes, let me get the screen back on here, there, and everywhere. There we go. possibility number 1 says that the opposite side, so again, to bring you up to speed, here is my A, here is my S, here is my S, this is my adjacent side, this is my opposite side, and this is Scenario number 1 says that the opposite side is equal to H. Can happen. And it's nice because then you get 1. We got the picture. You get 1 right triangle. And you can use SOHCAHTOA to solve. Second case is that the opposite side, so again, let me bring you back up to speed. Here's my angle. Here is my side. Here is my side. This is my adjacent side. This is my opposite side. And this is my height. Second scenario says that the opposite side is smaller than the height. And in this case, now let me see if I can do it. In this case, if that is truly the case, this side would swing through here, but would it ever complete that triangle? No, it never completes that triangle. Even if we get really, really close to that length of that height, it never completes that triangle. So therefore, no triangle is formed. Which leaves us with the true ambiguous case. So if you're in all of these scenarios, so going back up to here, so if we are in an acute angle that's given, if we're in the adjacent side is bigger than the opposite side, and then we have to see if that opposite side is bigger than the height. If that is the case, if those 3 scenarios all work out for you, you get 2 triangles. I'll double color code these. Actually, they're already pretty much color coded. So then you'd have the side here, you'd have the side here, side there, height, height. This would be my adjacent side. So, in a nutshell, ambiguous case only happens if we have an angle side side. We're given angle side side. Okay? So that's number 1. Dealing with the angle, if your opposite side is bigger than your adjacent side, you will always get 1 triangle. Doesn't matter if that angle is acute or if it's obtuse. You get one triangle, no matter what. If the opposite is less than the adjacent, so if the adjacent is bigger than the opposite, you could get 0, you could get 1, or you could get 2 triangles. If you're dealing with an obtuse, if you're dealing with an obtuse angle, you're going to get 0 in that scenario. If you're not, if you're dealing with an acute angle, the first thing you check is you find, I shouldn't say check. Let's not say check. Let's say find. I like find. You're going to find the height of that triangle, because that's going to tell you if there's 0, 1, or none, or 2 triangles. So if H equals the opposite, then it's 1 right triangle. If the opposite, if H is bigger than the opposite, then it's none. But if the opposite is bigger, then it's 2. No. Because here, I'll show you back on my swinging one. So if my opposite is bigger than my H, I'm going to get one out there, okay? Because I would have to extend this side all the way out. And then I would get one in there. All right? Let's do it. Let's do this. So, first off, it doesn't have to be any pretty triangle, okay? Because you don't know what kind of a triangle it's going to be just yet. You don't even know if it is a triangle just yet. Okay? So the picture, you should always draw yourself a picture. Okay? So I'm going to call this angle A. Oops. Okay? So I'm going to call this angle A, and that's going to be 42 degrees. Which means that side A here is 22. Does it matter which other one is side B? No, doesn't matter either way which other one is side B. I'm going to call it there, which then that's going to make this be angle B, and then we'll call that angle C. Yeah. So, what kind of a case am I given? Side, 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 angle, 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 side, hypotenuse, leg, or the ass case? Angle, side, right? Okay? That means we're open to ambiguous. Okay? So that's the first thing that you need to do. You need to determine that this is an angle, side case. Now you need to determine, I'm going to go back to my checklist here. Okay? So we know, we just figured out that it's an angle side-side case. Next thing we should look at is which of the sides is bigger, the opposite or the adjacent side. Which side's bigger? Opposite is bigger. How many triangles get formed? Nope. Just one, right? Okay. So it's not the ambiguous case. So just one triangle got formed because we're dealing with the opposite side is bigger than the adjacent side. So that is our only triangle. Okay? Let's solve it now. So we know I shouldn't say A. This one. So first, we know that the sine of 42 degrees over 22, law of sines, is equal to the sine of angle B over 12. Agree with that? Okay? So we can solve for angle B, right? Okay? Let's do it. So then this would be 12 sines of 42 degrees divided by 22 is the sine of B. Inverse sine of 12 sines of 42 divided by 22 would be angle B. Okay? Now, I want all of you to type this in your calculator because I want you to get the right answer. And so how you type this in your calculator is going to depend, and you need to know how to use your calculator. You should get that angle B here is approximately 21.4064 degrees. My TI Inspire calculator rounds to 6 significant figures. We'll tell you what to round to. But because we're going to use this later on, I keep it. Yeah, round to at least 4 for right now. Okay? Everybody in agreement with that? So now we know 2 angles in our triangle, which means that the second thing that we can do is we can say that angle A, which is 42 degrees, plus angle B, which is 21.4064 degrees, plus angle C is 180 degrees. So we can find that angle C is 116 point, so what would that be? 5, get me to 936. Okay? And now the third thing that we can do is we can say that the sine of 42 degrees divided by 22, I always go back to the one that we know for sure. We use angle B in 12 while we rounded angle B. So our answers are going to be significant. I should say significantly off, but slightly off. Equals the sine of angle C over side little c. So some cross multiplication here would give me C times the sine of 42 degrees equals 22 times the sine of 116.5936 degrees. That's going to give me I get 29.4001. Okay. Now, on a test, which right now is looking like March 16th, okay, on a test, we would say round, I think we say round angles to the tenths and round sides to the hundredths, okay, something like that. More than likely, I'll probably change it and round them both to 2 times. Okay? Good on that one. Love it. Think you're ready to try one on your own? Yeah? Solve me that triangle. I'll check back in like 2 minutes of actual time. Video time, it'll be like not even 2 seconds. Spot check. What kind of a case are we in? Angle side case, right? Okay. So just so that it's all set up the same, I'm going to put angle C here, and that's going to be 85 degrees. Side C is going to be here at 15, and side A, I'm just going to put it up here so it remain consistent at 25. Okay? So it is an angle side case. Yes? Okay. What do we have in terms of opposite and adjacent? Which one's longer? The adjacent is longer. What does that mean? It means we first got to find the height, correct? Okay. So that's the height. So if I'm looking at that, now, let me see. Let's go this way. No, we'll go this way. So I'm looking just at that triangle. What do I know about that triangle? It's a right triangle, which means I have SOHCAHTOA available to me. So the sine of 85 is going to be what? Or h in this case. Yep, h over 25. Which means then that h is going to be 25 times the sine of 85 degrees. Which is going to be approximately how much? 24.9? Okay, so now I have to compare put A there. Part B, I need to compare H and my opposite side. My height is 24, my opposite side is 15, so H is bigger than my opposite side, yes? What does that mean? No triangle. Now, the beast. Guess what? There's going to be two. Okay? All right? So let's first get it set up. Yes, we're in an angle side-side case, yes? Oops, sorry, I went A. That should have been B. My fault. Put them in the wrong spot. I turned around and I saw faces of horror. And I'm like, happy. Okay? Had to ease back into the school thing too. Okay? Still an angle side-side case, yes? Okay. Still, an adjacent is bigger than the opposite case, yes? So that means we need to check H. So the sine of 32 degrees is going to equal H over 7. I get my H is 3.709-ish. Huh? So that tells me that I'm comparing H to my opposite side, and my opposite side is bigger than H, yes? So that means I get 2 triangles. Here we go. So my first triangle. I have a complete pair, yes? Yeah, okay. So let's go with it. The sine of 32 degrees over 5 is equal to the sine of angle A over 7. Agree? Okay. I'm going to call it, though, angle A sub 1, because it's the first angle A. Quick solve. I get angle A sub 1 is 47.8924 degrees. Agree? Okay. If that's the case, then angle C sub 1 is going to be 180 degrees minus 32 degrees minus 47.8924 degrees. And that's going to give me angle C sub 1 is 100.108. Actually, 1076. Agreed? Then I can say again that the sine of 32 degrees all over 5 is equal to the sine of 100.1076 degrees all over side C sub 1. And I get side C sub 1 is 9.2890. Yes? Okay. So that's all that I just solved there, my first triangle, using law of sine. Okay. Now, here is the kicker. Now we're going to go to our second triangle. And the first thing that we're going to do is angle, I'll put this in my favorite color, angle A sub 2. Because angle A was the first angle we could solve for in our first triangle, it's going to be the first angle that we solve for in our second triangle. Okay? And angle A sub 2 is going to be 180 degrees minus angle A sub 1. Which I think somebody over here said earlier when we when it started with the bait, that the angle that I came up with and the angle you came up with were supplemental pairs. I don't know. One of the two. No? So angle A sub 2 is going to be 132.108. Actually 1076. Sorry, I forgot we rounded to 4. Which means now we can find angle C sub 2. $15.8924 degrees. Here's the best part of it. Okay? Provided that you wrote out all of this work over here to find side C sub 1, the only thing that changes from that work is your angle C. So you can go right to side C sub 1 is 5 sines of, now instead of angle C being 100 degrees, angle C is 15 19.8924 degrees. And if you've got a fancy type calculator, you can just scroll up and just change that one and hit enter again, and boom, it's there for you. Yeah? So that's the nice part. Oops, this should have been side C sub 2. Not side C sub 1. I get 2.5837. All right. So I apologize, but that's kind of why we saved this day for a 4-mod day, because having to like start and stop this doesn't do very well. So, okay. So there you go. That is the ambiguous case of the law of sine. Okay. So again, we were supposed to take a formative today, where we changed that again to a take-home formative. So I will hand that out now. We ask that you have these. It's a 3-question formative. It's all on 5-3, 5-4 stuff. So sum and differences, double and half identities, solving, that kind of a thing. Okay? That formative due tomorrow in class.